this morning that it's pretty fitting that today is the 30th birthday of the World Wide Web. And just a funny story that made me think of, when my parents met in 1980, my mom called her cousin and said, this guy I went on a date with, I mean, I like him a lot, but he's a little weird. He has a phone line for his house and one for his computer. Right? And now we all are walking around with little computers, in our pocket all the time. So what was weird in 1980 is totally normal and is completely different today than it was in 1980. Yeah, so like I said, I'm a school counselor in Pennsylvania who just loves this topic and helping think about our role as advocates, as school counselors. So I love the macro aspect of thinking about the big picture. I love micro, working one-on-one with students. And I'm hoping that today through this session, and those of you who are able to attend our session later and watch that you'll see that advocating and increasing education and increasing the diversity of computer science is a social justice imperative. So I'm really excited to be here with you. Whenever I go to school counselor conferences, I leave really energized, and I bet you guys will today too. So we're going to start with a little bit of interaction using my good toolbox for counseling lessons. So you all are going to be programmers today, and we are going to learn to program a robot to draw. What you need to do, I'll give you a minute, is pair up. If you have an odd number, you can do this in a group of 3. Get two pens, you only need a pen, and a piece of paper. I noticed the back of the menus are blank, so if you don't already have a piece of paper, every person will need a piece of paper and a writing implement. Okay, if you are in a group of 3, one person is going to be the programmer first, and the other 2 are both going to be robots. Your mission is to get your partner, the robot, to draw the image that you have designed. You will have to give precise instructions in the right sequence. Okay, we'll go through this. So your robot is equipped with voice recognition software. It can understand draw up, draw down, draw left, draw right. It knows very simple shapes, circle, line. It does not know square. It does not know arrow. Does not have a database of banks, of pictures or a lot, just kind of circles and lines. It knows some distance, so inches. It knows fractions, so if you're doing an angle, you could say 90-degree angle. And, well, the rest you'll have to figure out. So here's a repeat of what we need to do. When we start this, you're going to need to orient yourselves in a way that you cannot see what you draw. So the programmer needs to think of an image, draw it, and maybe sit back to back, so move your chairs back to back. Maybe take your programs and put them up between you battleship style, so it's a little barrier between you so you can't see what the programmer has pre-programmed. The programmer, think of an image in your head to draw. Now, let's talk through these a little bit. You don't want something too simple, so this U might be a little bit too simple. Okay. Like I said, you have angles, so it doesn't know arrow, but if you were to give them this image, you could think about the angles that you're having them draw, how long you want the lines to go. And you want to think about sequence. So if you were giving them something like the circle with lines, what would you start with? me a little reflection on this activity. Someone want to share with me? Just a little reflection on how easy this activity was. Not easy. I heard it not easy. Yeah. Yeah, so she said that when they switched roles, she felt much more comfortable taking directions than giving them. Right? The computer or robot doesn't really know. It's much easier. Sometimes it's harder to think through your own process than it is to hear the instructions, which we know in classroom management is sometimes the same as well, thinking about how do we get the students, how do we achieve and get the class to do what we need them to do, and thinking how do you give precise enough instructions. We do that with classroom management too. So how does this also connect to our role as school counselors and something called computational thinking? Have anybody heard the phrase computational thinking before? Okay, good. That's what we're going to talk about it. So when I was in school, we talked a lot about the scientific method, right? And disproving a hypothesis, and that was the order. Now, this is a connection of our school counselor to our other professions as well. We're thinking about computational thinking. So it's kind of the new buzz term in education, but really helps expand and is more interdisciplinary than just than our scientific method originally was. So these are the concepts of computational thinkers. They are using logic. They're evaluating the process. They're maybe using algorithms. So if you had a drawing, for example, that had a repeat in it. So I saw like a snowman that had a repeat. A programmer might not give the instructions to the computer every single time to draw that. Okay, it would actually write a code, a section that says this is how you draw a circle, and then it would say repeat that. Move down 1 inch and then repeat that program. Move down 1 inch, repeat that program. So instead of writing the program over and over, there's a lot of repeats. And so that's where our algorithm, our math comes involved. Okay, patterns. So again, if you had a recurring pattern in your drawing, breaking it down into the parts, which you had to do for this activity. You had to think about, okay, I drew a snowman. Now let me describe this part, this part, this part, because the robot doesn't know what a snowman is. Okay? And thinking about what's unnecessary. How do we get to the heart of what it is that we're drawing? And this is kind of the approaches then, or what does this look like? What does this look like when someone is using these concepts? So it's tinkering, it's creating, it's debugging. So that was one of the things when we repeated this, you maybe learned, okay, what went wrong? What can I do better? The group that had the ears on the inside than the outside, they said, wait a minute, I need to go back and figure out how do I describe that differently. Okay, persevering, keep going. Okay. If your output does not look correct, did anybody start over? Like I had one group that did it really fast and it wasn't right. I think there was a smile. Did you start over at all? Did you think about, okay, how do I do this again? Okay. And collaborating and working together. So those of you in pairs, thinking about the second time, how do you, maybe together, thinking about how do you tell the robot to draw this? How many of you are familiar with our ASCA mindsets and behaviors? Let me see, show hands. Okay, so these are ASCA mindsets and behaviors, and I'll just go over them because it didn't seem like everybody in the room. These are just a sample of them. So we had our ASCA, American School Counseling Association, core competencies, and the skills we wanted students to have. A few years ago, they rewrote them as mindsets and behaviors, reviewing the literature on what helps a student be successful. So let me decode this a little bit for you. First there was mindsets, and then there was the behaviors that we're looking at in any phase of life, whether we're looking at going right into a career, whether we're looking at the university setting, whether we're looking at students with disabilities, all forms, what are things that we need as humans to be successful? So the LS there are learning strategies. That a student can demonstrate critical thinking, skills to make an informed decision. This could be a decision about colleges. This could be a decision about how to react to something. Okay, gathering evidence from multiple perspectives to make a good decision. The SMS is self-management skills, so demonstrating effective coping skills when faced with a problem. We need to be able to do that as adults and to be successful. Demonstrate ability to overcome barriers to learning, so some of that self-advocacy, learning to learn for themselves. When they hit a wall, what do they do to keep going? And then we also have our social skills, because no man's an island, right? So using effective collaboration and cooperation. We got using leadership and teamwork in a diverse team. So that's key, that you can get along with a group of people and be able to do and collaborate together. So if we tie this into our computational thinking, we have some of these things relate. So it's really key in computational thinking to persevere. Computer scientists and coders do not get it right the first time. Okay? They've got to keep going back, figuring out where the bug is. And this ties to our own school counseling competencies of helping students find self-motivation, self-direction, of demonstrating effective coping skills when they're faced with a problem. Okay? So a lot of the things that we're teaching and we're caring about the whole being as a child, as a whole being, also apply to the ways that they're learning, the tools that they're using in many career fields, not just computer science. So this idea of computational thinking can apply to artists, it can apply to historians, it can apply to writers in terms of reviewing and editing their processes. It's a lot broader than just the scientific method was. And what does it mean for real world and jobs? So the World Economics Forum surveyed CEOs, and they asked about skills and things that they are looking for, both now and in the future, when it comes to the workforce. Complex problem solving, that's what they're looking for now. In emotional intelligence, which lifelong learning goals, but I also think emotional intelligence even applies to working on a diverse team, being able to work with people different than you. And that leadership. In the future, they're looking for technology, design, and programming, but they're still looking for complex problem solving, emotional intelligence, that participating in their own learning. Their own school counseling competencies have ripple effects to prepare children across the board for whatever their pathway is. When we look at computer science specifically, we're helping our students embrace a growth mindset. So in a lot of our other things, there's right or wrong answers. We're testing them on multiple choice where it's very clear whether they've gotten it right. Or in mathematics even, you can plug your answer back in and check it, and there's a right or wrong answer. In computer science, there's not necessarily a right or wrong answer. They're creating something, but there might be a lot of different pathways to create that same output. And so a student's ability to realize that they need to keep going if it's not working and think outside of the box. It's one of the most fundamental things when I talk with computer science teachers of the students that struggle, or they give up too quickly. So computer science now touches our lives in every way. And those that are currently creating the things that we're using are a pretty homogeneous group of people. Okay? And so one of our roles as school counselors is to dive into, think about this with our students, and thinking about who are the students that we're directing towards computer science. Who do we have a picture of this for? And so we'll get into that as well. Because really, right now, it literally touches everything. So every area of our lives, my cat just had to be in the picture. He just wouldn't let me out. So let's think about ourselves for a moment. How has computer science changed our profession? Okay, not necessarily thinking about our kids' lives, but our own jobs. So if you would get out your phone if you have one, or you can do this in pairs if you're not on, and go ahead and participate with me on this Padlet, thinking about how has computers and technology changed our own profession so far. So go to padlet.com/Dana Wile / and then this is also the hashtag for this event, OKFCO19. Okay, and then you can click anywhere on here and add in, or you can click this little X down here and you can add in an answer. So padlet.com. It's allowing us to have continual professional development, giving students access to our tools, reducing the printing cost of our schools. I know our tech directors are happy about that. The data piece. We as school counselors are equipped to analyze and look at data with our students. Printed college books. So we used to have printed books that students would come in and look through and flip through for looking at colleges, different majors. All those resources are online now. Let's see. The records, keeping records. Giving students and families access to information. I see collaboration with staff, engage with students. My school this year started online appointment scheduling with students. And sometimes it affects our profession in a negative way. For example, I see I can't even answer my phone if the network's down because our phone and our computers are tied. Right? Technology is a great tool, but it's not necessarily a good savior. I was actually going to do a different thing today, and I was on it last night called Answer Garden instead of Padlet, and their server's down because they're upgrading to like wind energy in like the Netherlands or something. So their whole website was down. I was like, quick, had to use something else. So technology isn't always the most reliable thing, but that's the thing about teaching our kids computational thinking skills, is that it's teaching them to think outside the box, work on the fly, collaborate together. I'm quick texting people saying, hey, do you remember if anyone can use this? I can't remember what this tool is called, so I'm collaborating to solve my problem. Computational thinking in my everyday life, right? So if you have more you want to add to that, you can do that. That'll stay live. Technology affects every field. Okay, so in the medical field, someone is working on developing contacts that measure your insulin level. So someone could wear these contacts instead of needing to prick their finger or have a big device on them. Right? Obviously in space, technology is extremely important. We even have robots, so not only the technology to get humans to space, but just our robots are exploring for us. So we don't necessarily need to send a human somewhere. Our animation, our entertainment is technology-based. How many people here, their kids want to be YouTubers? It's like the new career. My kids say, I want to be a YouTuber, right? Well, it's not just about recording themselves. They got to learn how to edit those videos in a way that are engaging, right? That's using technology. Our driverless cars. The one that's really interesting to me is thinking about our connected homes, like the Nest. And it's a good example of why it's important to have a diverse team creating the Nest and these technologies in our home. one of the problems that originally started to surface with these connected devices in our home was domestic violence. So one partner in a relationship would set up a connected home, okay? And something would happen and in a domestic violence situation, and the abuser could be court-ordered to leave the home. But the way these tools were originally designed, the person that set them up was the only person that had access to grant permission rights to use it. So the abuser could be somewhere else in the world controlling the heat and the temperature in the home and getting access to now the person in the home. That connected device belonged to the user that originally created it, not the home. So he could freeze out or she could freeze out their partner that they're abusing or overheat them. Okay, so that was a big problem that I think if a more diverse team had been creating that would have been thought of earlier in the process. You know, they're working on, they fixed it now. There's other ways to do that. But that's a prime example of a diverse team, a group of women from all walks of life, not just those who are privileged, had been at the table creating that, may have thought through that issue of who owns this device. You know, how do you have something that's secure, but also isn't going to then be turned into a tool of manipulation? So one of the things that our role as school counselors to think about is everyone should have access to the basic fundamental views of this as counselors. Okay? How many of you learned about photosynthesis in school? All right, raise your hand. Has some idea, whether you remember all the basic parts, you kind of know how photosynthesis works, right? How about your digestive system? Okay? You might not remember all the technical names, but you learned about how the system works. And it's important in this day that everything's so easy to use without understanding it works that we go back and revisit, do we understand how this works for our students? And do we need to all understand how it works as school counselors? Not necessarily, but advocating for that in our curriculum and our students and thinking through that. In our session later, when you watch it, we're gonna dive into the details of like, how do you do this? Okay, because we run into the same problem that math does, where girls in first, second, third grade love math, but by middle school or high school, they're like, oh, I don't like math. Right? So we run into that same problem. So we're going to dive into that a little bit more. So one of the cool things that I think about when we're career advising is to think about how two things can mesh together. So there was this one woman who majored in computer science, but her secret passion was to be a model. Okay? So she went ahead and followed the traditional path, and she went and got a 4-year degree in computer science, and then she said, you know what, I'm gonna try this. I'm gonna go to New York City, I'm gonna be a model. And guess what, she made it, okay, as a model. But one of the things that she found as she's doing this profession now as modeling is that there was no good digital way for models to have their portfolio. They're going and printing out these big pictures, they're taking these folders. And so she went back and used the things that she learned with computer science to make an app for models to use with their digital portfolios. And she did it better herself than she would have if she had commissioned somebody else to make it for her. When I have technology problems, my school uses Sapphire, I always think, man, if more teachers and educators actually knew how to code, this probably would work a lot better than me trying to describe to somebody else what I need it to do and then make it and this back and forth. So when we're advising our students, where are the things that you can find intersectionality? We all became school counselors because we wanted to help people, right? Helping students see technology as a way of helping people is a message that we need to start really early on with students, is how do you help change the world with these tools? And the cool thing about this computational thinking and computer science is once you get the basis down, you can go many different directions with it. So a lot of times my advice for high schoolers is just pick up a minor in it. If you can pick up a minor in computer science and learn just a couple basic coding languages, right, then the sky's the limit on what you can do with that later. It's kind of like, anybody who's multilingual, once you learn a couple languages, those people who are really good at linguistic languages. Once you learn a couple, it's much easier to learn something else. And that's the same way with computer science. There's some basic rules to it. There's some basic guidelines that once you get the foundational concepts up. This is imperative that we learn. Not everyone needs a major in something computer-based. If we could get it in our K-12 schools, that'd be even better. But if not, what are the ways that we can help draw connections to people? So if you want to share at your table just for a moment, another area, so I had modeling and computer science as an example, right? Some other example of a profession that someone majoring and minoring in two things might be a really good partnership. So share at your table and I'll come around and get some ideas. Have a family friend whose bachelor's degree was in computer science. He then went to med school, and he is half of the time out with patients in the hospital and half of the time working with the program that the hospital is using on the computers. And being in that dual role is making it much more efficient for doctors when they're sitting there with patients to be able to do the computer stuff while they're engaging with patients, because someone that is both doing it and knows how the system works, is designing it, is fixing it, is tweaking it. And so yeah, the same concept with nursing. Yeah. Any other, some other fields that you were giving examples for? Did you?
Data management system.
Okay, a new student data management system. Yeah.
And so we have the techie people who work on it, but we are the ones that need understand how we need it to work for us.
Yes, absolutely.
So having someone, we have a teacher, former teacher principal, who's now overseeing that.
Okay. Yeah, and so having in our own field, in education, right, having educators that are involved in the process, and now having someone who is, you said an administrator?
Former teacher and principal.
Yeah, former teacher and principal that's now working with our new data management system. Yeah, that's it. Yeah, education and technology. Yeah.
There's a store in our community that a new Jiffy Trip, when it was a convenience store place opened up, and they came to our school talking about it. They're building a new one in our store. They'll get an app they're going to have available. And part of the app is going to be allow the parents to prepay for gas for the kids, so that the kid can just go there and have the gas already paid for them ahead of time.
Yeah.
So
So it was like a quickie mart type of thing that they had an app. Parents could prepay on a gas card for their teenagers to fill up on gas, right? That is one of the interesting things. So in my area, I don't know if anybody's ever been to the Northeast, but we have two convenience stores that are like big chains out there, Sheetz and Wawa, and it's like a fight, like, right? And I think and Turkey Hill, right? Who's gonna dominate? And one of the predictions is it's whoever can make the best app is the one that's gonna win, because everyone wants mobile ordering. McDonald's right now, mobile ordering, right? A lot of the McDonald's are upgrading around us. And the thing is, there's not enough people to program these. The cool thing is of all the tech jobs in the nation, only 50% of them are actually in the tech industry. So when you're looking at tech jobs and searching them, John Deere is hiring people in technology, right? New York & Company, a clothing line, is hiring people in technology. So anything you're interested in, you can kind of work and influence that industry if you have some technology background. Okay. Anybody else want to throw out an example? See any hands? Okay, great. So as we're expanding and thinking this, some of these things start at a young age and thinking about who am I as a person. So we know that people are influenced in careers is, do they see themselves in the career? Were they encouraged in the career? Do they even have exposure? One of the major flaws, I think, as a profession is that we often are using interest inventories, like the Hollins Code. The thing is a student can't self-report they're interested in something if they haven't had exposure to it. So of course someone's gonna say, oh, computing is low, if they've never had any exposure to it. And so I would encourage you to look at code.org and some of the other resources. We have a table out there to start to explore what are just some things when you're doing this that you can expose your students to computer science in a way that has people that look like them, can they picture themselves, that sees it's collaborative. One of the best examples I had was I was doing a presentation to counselors in Philadelphia, and we invited the head of the computer science program at Temple University to present, and she talked about her interest. And she said that she went to a technical school for high school. They said that's kind of the way out of poverty in our area. And she chose something, and I can't remember exactly what it was, but I think it was something like culinary. And that's what she chose. And as she walks in every day, she sees the kids over in the computer networking all huddled around a computer and high-fiving when they got something right. And she says, that's where I want to be. So many people these days think computer science is sitting there all by yourself, but it's such a team thing that we don't often, our media and even us as counselors, don't often describe or understand, but it really is a team environment. So this woman, who's now the head of a computer science department at a university, exemplifies that, whereas a female, she connected with the teamwork aspect. So we need to make sure that we're talking about computer science and we're choosing resources that reflect, that students can see themselves in, that reflect the things that statistically appeal to us. Saving the world, we want to help people, right? We want to work with people. And this is a way that we need to shift our own mindset to help our students shift their mindset, that this is something that anyone can do, that we need everybody at the table, because I hope that one day my own daughter is using technology created by women, created by a diverse group of people that can make sure that there's equitable access and fair use of these tools for everyone.